In this video, we will go through Statistics Assignment 2.3. The first question asks us to use the plot to find the medians and the quartiles for each group of predators. So what I like to do when I do this is I mark off the numbers as I go. So the lowest number here in the predator group is 1, and the highest number is 25. This is a little bit hard to look at, but this actually goes 0, 0, 1, 1, 2, 2, etc. It split the numbers into groups of 5 instead of groups of 10. Anyway, I'm going to keep following this pattern going from the lowest to the highest, and what I see here is that my median is going to be right in the middle, right there at 12. So for the predators, the median is 12. Now I'm going to think about the quartiles, and I actually think it's easier to find the quartiles by lining up the numbers. So the first number is 1, then 5, then 7. Then I've got, 5 12s. Then 15, then 16, then 25. So what I did, again, is I just, What I did was I rewrote these numbers. 1, 5, 7, and so on. So I'm going to number my numbers. Which seems like kind of a strange thing to do. But when I do that, I can see that I have 11 numbers. And when I number my numbers, I also can see that indeed my middle number is 6. There's 5 numbers below it, and there's 5 numbers above it. Then to find my quartiles, I go to the numbers below the median, and I take the middle number of the numbers below the median. So the middle number of the first 5 numbers is 7. So this is my first quartile. Then I do the same thing with the numbers above the median. 15 is the middle number of the 5 numbers above the median, and that's my third quartile. So now I can write that down. The first quartile is 7, and the third quartile is 15. Remember, I'm looking at this top row of numbers. The bottom row is just me counting the numbers to make sure I'm doing this correctly. Okay, I'm going to do the same thing for the other numbers, and I'm going to start down at the bottom, and I'm going to write, this is 3, and then 4, and then 5, and now I'm going to go kind of fast. Okay, so I wrote out all the numbers, and now similarly I'm going to number the numbers. By the way, you could also use Rossman Chance to do this process. But with 27 numbers, the middle number is the 14th number. And then I will have 13 numbers below that 14th number, and I'll have 13 numbers above it. For the non-predators, my median is 14. Whoops, no it's not. That's a mistake. The median is this number, it's 12. Okay, now I'm going to find the quartiles. So again, I'm going to look at the numbers below the median. So the middle number in the first 13 numbers is 8. And the middle number in the second, or the last 13 numbers is 1, 2, 3, 4, 5, 6, 7 is 15. Okay, So now I'm supposed to compare the two distributions. So when I compare the center, I would say the centers are the same at 12. The spread of the non-predators is greater. It goes from 41 to 3, or it's a span of 38. The predators have a span of 25 minus 1, or 24. So 38 versus 24. And then, what else do I want to say? They're both skewed to the right. This is a little bit hard to see when something is vertical like this, but the higher numbers are, can't write and speak today. The higher numbers are on the right side of a number line. So we would say that they are both skewed right. Okay, let's keep going. Estimate the 5-number summary from this box plot. The 5-number summary is the minimum, the first quartile, the median, the third quartile, and the maximum. So I'm just going to estimate this right off of the number line. The minimum is about 10. The first quartile is about, looks like that's about 30. The median is about 38. The third quartile is about 41. And the maximum is about 70. And that's what a box plot tells us that 5-number summary. Okay, question 4. Would you use the mean or the median to measure the center of the following sets of data, and why? The prices of single-family homes in your neighborhood. Okay, so to answer a question like this, if the data is skewed, we're going to use the median. And the reason is the median is less resistant to outliers. So I'm going to use the median because in my neighborhood, most of the houses are kind of normal houses, and then there's a few fancy houses. There are a few outliers. And it does depend on the specific neighborhood. So this is asking you to read into the question a little bit. The yield of corn. Okay, so this also is probably going to be skewed. You're probably going to have a few farms that had a bad year. And so I would suspect that the data is going to be skewed one way or the other. ACT scores. This is designed not to be skewed. Standardized test scores are designed to be normally distributed, and in general they are. So it actually doesn't matter if you use the mean or the median because it should be the same number. Okay, next, E26. The test scores of 40 students in a first period class were used to construct the box plot, the first box plot in the display. So this is our first period class. The test scores of 40 students in a second period class were used for the second. Can the third plot, so that's this one, be a box plot of the scores combined? Why or why not? Well, let's just take a close look at the min and the max here. Here's the min and the max for the first class. Here's the min and the max for the second class. Now you'll notice in the third graph, the min is at 20, which means this graph cannot include the data from the second graph, because where is this person? Where is this lowest score? It's not here. So the answer is no, because it cannot include the second. The minimum is not 10, as it must be. Question 6. The mean of a set of 7 values is 25. 6 of the values are given. What's the 7th? So if I take 24 plus 47 plus 34 plus 10 plus 22 plus 28 plus some unknown value and divide by 7, it should equal my average of 25. So this is the toughest algebra we're going to do in this class. What we're going to do is we're going to multiply both sides by 7. And 25 times 7 is 175. And then I'm going to add the numbers on the left together. So I'm getting out a calculator here. 24 plus 47 plus 34 plus 10 plus 22 plus 28. So that's 165. So I just got 165 plus x is 175, and perhaps you can see x must equal 10. Number 7, no computing should be necessary to answer the following. Find the mean and the range of each data set. Okay, the mean here is 20. If you did want to compute, you would add these all together. So 10 plus 20 is 30, 30 and 30. So this is 100 divided by 5. And then the range is the max minus the min. That'd be 40 minus 0, which is 40. The next one, we're going to get the same thing. 20 plus 40 is 100 divided by 5 is 20. So the mean is 100 and the range is 40. Guess what the third one is? The mean is 20. The range, the maximum value is 40. The minimum number is 0. So the range is 40 minus 0, or 40. Which of the above has the largest standard deviation? Okay, so this is why we studied mean absolute deviation. Which is the most spread out? So I would have to go with this one. And the reason why is there's one data point in the middle, and then the others are spread as far away as they possibly can be. And then the smallest standard deviation will be the data that is clustered closest to the center, which would be the third one. So for the answer, which has the largest, would be the second, which has the smallest, it would be the third. Number 8. 2 of the following sets of data values have a standard deviation of 5. Which are they and why? All right. Well, this first set of data has a standard deviation of 0. Oh, that's kind of a weird shape I just made. I want it to be a circle or an ellipse. Let's try that again. Oh, weird. Okay. Well, anyway, the standard deviation of this is 0. Okay. So we're looking for an average distance from the mean. On this one, the mean is 15, and 10 is 5, 15 minus 5, and 20 is 15 plus 5. So I think this one's a good bet to have a standard deviation of about 5. The next one, if the middle number is 14, the average distance, let's see, look at these distances. That's 2, this is 4, this is 6, this is 8. The middle of that is 5. So I think this one is also a good bet to have a standard deviation or an average distance from the mean of about 5. This one, I think, is the standard deviation is bigger than 5. Because if I do the same thing, this distance is 5, this is 10. Look, they're all getting bigger. These aren't going to average out to 5. They're too big. So the standard deviation is too big. So these two in the middle are our best bet. Standard deviation of, okay, now we're on number 9. Standard deviation of the first data set is about 30. What is the standard deviation of the second data set? Okay, so I want you to notice something here. If I take 16 plus 4, I get 20. If I take 23 plus 4, I get 27. Guess what? If you add 4 to all of these numbers on the left, you get all of these numbers on the right, which means the spread doesn't change. We added 4 to every number, but that doesn't spread out the data. That just shifts it up. So the standard deviation is still 30. Okay, in number 10, match the histograms with the box plots. Okay, so what we're going to do here is we're going to look really closely at the bottom here. This one, it's kind of hard to see, but it goes from 8 to 12. In the middle is 10. This one goes from 13 to 16. And this one goes from 12 to 16. This one's skewed a little bit left. This one's skewed a little bit right. So coming back over here, the 8 to 12 one, this has got to be A. That's got to be this one. And then the one that starts at 13 is B. And then the one that starts at 12 has got to be C. Question number 11. Find the mean, the standard deviation, and the 5-number summary for the set of numbers. What I'm going to recommend here is that we put this into Rossmann Chance. So I'm going to go to Google, go to the Rossmann Chance applets, and go to descriptive statistics. And I'm just looking up my numbers here. So I'm going to clear this data, and then I'm going to go back to my numbers, and I'm going to type them in, 40, 58, 62, 70, and so on. Again, it can be really helpful if you have a friend or a partner that you can have read this to you. Oops, okay. Sorry for the delay there. Okay, oops. So then once I have my data in there, I'm going to click Use Data, and I'm going to click Mean, Median, Standard Deviation, IQR, and over here I can see the mean, the median, the standard deviation, and the IQR. Let me screenshot this. So this IQR stands for interquartile range. And it is the third quartile minus the first quartile. So the third quartile is 97, and the first quartile is 72.5. So my mean is 81.06, essentially. The standard deviation was 16.7. And then my 5-number summary, the minimum is 40. The first quartile is 72.5. The median, the median was 82, and then my next number is 97. Pardon me. Okay, so that is that. All right, we've got one left to go. So on this one, when it says use your calculator, we're actually going to use a iPad to do this, and we're going to use Google Sheets. So if you do have a TI-84, you can do this function called one-var stats on lists to solve this, but we're going to go ahead and try to solve it using our iPad. So once again, I'm going to switch over to Google Sheets, and I will, let's see, we'll just start a new one here. Okay, and then I'm going to enter my data. Hey, go! All right, I got the first row done. Now I'll do the next one. So this question is asking us to find the mean and the standard deviation of this data. And so what I'm going to have to do is, this is something called a weighted average. What we're saying here is we're saying that the number 2.99 occurs one time, and the number 3.01 occurs 4 times. So you can see how, this is more convenient to write than to say 3.11 and to type that 24 times. This is a much faster way to do it. But if I want to add all of these numbers together, to find the mean, I'm going to have to use a formula. So what I'm going to do is take A1 and multiply it times the number of times that occurs. So that's A1 times B1. And then I'm going to take that formula and I'm going to fill it down. So now what I have is I have the sum. So for example, 3.11 times 24 is going to equal 74.64. Now, the sum of this can be calculated using a formula. So I will type in equals the sum of C1 to C12. So there's the sum. And then the average is going to equal the sum, which was this answer, 310.95, divided by the number of numbers, and the number of numbers was 12. So that's 25.9. So my average would be 25.9. So I'm going to leave it as an extra credit problem for you to see if you can figure out the standard deviation. For now, we'll just say the mean is 25.9. And again, if you can figure out the standard deviation, that is extra credit. All right, thanks for listening. And as always, ask questions in class if you need to.